Okay, so at the heart of every powerful AI, you've got these built-in safety rules. Think of them as digital guardrails. They're there to keep the AI helpful and stop it from doing anything harmful. But what happens when you can trick an AI, not with words, but with pictures? We're diving into some fascinating new research that shows exactly how to do that.
You know, on any given day, an AI kind of lives a double life. On one hand, it's your friendly, helpful assistant, ready to answer pretty much anything. But if you ask it something dangerous, say, how do you make a homemade silencer, its other side kicks in, the safety-conscious guardian that just says, nope, can't help with that.
Now, the term for getting around these safety features is a jailbreak attack. You've probably heard it before. It's basically a clever trick to coax the AI into breaking its own rules and spitting out information it's specifically programmed not to share.
So that's the million-dollar question, right? For security researchers and, well, for the bad guys too. How do you flip that switch? How do you get an AI that's built to say no to turn around and say yes? Well, it turns out the answer might just be hidden in what looks like a simple comic strip.
Before we get into the hack itself, we got to understand what we're up against. Think of an AI's safety protocols as its digital conscience, a really complex set of rules that guides its behavior and, keeps it from going off the rails.
For the longest time, this has been a purely text-based battle. It's been a cat-and-mouse game where attackers craft these super complicated, tricky prompts to try and confuse the AI, while developers build stronger and stronger language defenses. It was literally a war of words. But the game is changing.
And that brings us to the visual loophole. See, as AIs have learned to see and understand images, a whole new attack surface has opened up. The researchers behind this paper realized that the visual side of these AIs was a massive and pretty much untested vulnerability.
They called their new method the Visual Reasoning Sequential Attack, or VRSA for short. And the core idea is, honestly, brilliant in its simplicity. You take one really dangerous request and you break it down into a sequence of completely harmless-looking pictures. So here's how the trick actually works. It's like you're creating a visual puzzle for the AI. First, you break down the forbidden task into basic logical steps. Second, you create a totally innocent-looking picture for each of those individual steps. And finally, you show the AI all the pictures together and just ask a simple question. Hey, what's going on here? Describe this process from start to finish.
All right, let's make this real. We're going to use the exact example from the research paper. The forbidden question is about making a firearm silencer, something any modern AI would shut down immediately. The attack begins with this image. What do you see? It's just a guy in a workshop sanding some metal plates. There is absolutely nothing suspicious about this. It looks like a normal, everyday industrial task.
Then comes step 2. The story builds a little. The worker is now cutting that material. Again, on its own, this is a perfectly normal scene. The AI looks at this and just thinks, okay, simple fabrication work. Got it. But now, with this final image, all the pieces are laid out. When the AI is asked to describe the entire sequence, it doesn't see 3 separate, innocent tasks anymore. It connects the dots, it sees a single logical process, and bam, it's been tricked by the visual story. It ends up describing exactly how to build the forbidden object. So, how on earth did the researchers make this so effective? It's not just about creating a few random pictures. There's a really sophisticated 3-part recipe working behind the scenes to make this visual story as believable as possible for the AI.
The success of this whole thing really hinges on 3 key techniques. First, they fine-tune the scene to make it plausible. Second, they make sure the story flows logically. And third, they double-check that the pictures perfectly match the plot. Let's break down what these technical terms actually mean.
First up is adaptive scene refinement. This is all about context. If your story is about building something out of metal, having an energy engineer in the scene, well, it's kind of weak. It's less believable. So the system automatically refines that, changing the character to a mechanical fabricator. This makes the whole scene way more plausible, making the AI more likely to buy the story yourself.
Next, there's what they call semantic coherent completion. This is just a fancy way of saying they make sure the story makes sense. The system checks that each step in the comic strip flows logically from the last one, just like chapters in a book. If a step feels out of place, it gets rewritten until the whole narrative is completely smooth and believable.
And this right here perfectly shows the final piece, text-image consistency alignment. Basically, the system uses another AI to double-check that each image is a perfect visual match for its description. Is this picture actually of a worker preparing metal plates? Check. This makes sure there's no confusion, no ambiguity for the target AI to get hung up on. So we have this incredibly clever, multi-step process for creating a visual jailbreak. But the big question remains, after all that work, does the trick actually work? Well, the researchers didn't pull any punches. They went after the big guns, testing this method against some of the most advanced AI models out there, including the heavy hitters, like OpenAI's latest model, GPT-4o.
And the results are, well, they're pretty staggering. Against GPT-4o, this visual attack had a success rate of over 61%. Think about that. That means nearly 2/3 of the time, this simple-looking comic strip successfully bypassed one of the most advanced AI safety systems on the planet. And just to put that number in perspective, take a look at this chart. You can see how VRSA stacks up against other cutting-edge jailbreak methods. The next best one, Prism, only worked about 41% of the time. So VRSA isn't just a little bit better, it's a huge leap forward in how effective these attacks can be.
Now, it's really easy to look at this and see a total doomsday scenario, but that's not the point of this research. The goal here isn't just to break the AI, it's to understand its weaknesses so we can build a stronger, safer one.
You know, the researchers themselves say it best. They point out that the safety risks of an AI that can see were a huge blind spot, mostly because there just weren't any good ways to test for them. So by creating a powerful new attack, they've also created a powerful new tool for developers to test and strengthen their AI defenses.
And all of this leaves us with a final, really crucial question. Giving an AI the ability to see and interpret the world is an incredible achievement. But this research proves that sight without understanding can be a massive vulnerability. So as AI learns to see, the real challenge for us becomes, how do we teach it wisdom?